Hi, welcome to the second of a series of videos I'm making to take you through my workflow of creating a custom PCB. Um, Keep in mind that I'm just a hobbyist, so I might not have the best practices, but uh, I'm usually successful in my designs. So this time around, I'm creating a uh, project for my Learn to Solder classes, hopefully. Um, One of my favorite things to do when I was teaching Arduino at Christmas time was to do the buzzer music, Christmas songs, and then flash LEDs or NeoPixels along with them. So my idea is to port a Arduino Uno program for buzzer music and NeoPixels down to fit on the ATtiny 85 and make a custom PCB shaped like a tree around that. So the first video showing on the screen there is where I talked about the process, and we prototyped the circuit and ported the code over to fit easily on the ATtiny 85. So you probably want to check that video out first to get an idea of what we're doing. Anyhow, so this video is going to be about my design, the actual design of the PCB. I'm not going to go into the basics of using the Easy EDA software. I learned everything online using Ralph Bacon's excellent couple of videos to show you how to get started with that. They're a couple years old, but I think they're still relevant. I'll link to them in the description if you're interested in finding out something. One thing is that I really wanted to make this a tree-shaped PCB and probably have the silk screen of a tree on it as well. And so I'm going sort of backwards on this project, or this video at least. Is I'm going to show you how to design the outline of the board, custom outline of the board, and get some silk screen, and how to import that into Easy EDA. If you're first starting out, you're probably going to make just a rectangular one, and Easy EDA kind of does the rectangle board for you, outline of the board for you. So this is maybe a little bit farther along on your second or third board. You might want to try to do this custom thing. Anyhow, for the outline of the board, you're going to need a DXF file. And for the silk screen, you're going to need to import an image file. So for those that have been following me know that I recently purchased a laser engraver, and I got used to using Lightburn software, and I can work with that and get the outlines and everything that I need. You could probably I'm sure you could do this in Inkscape. I haven't played around with it, but I'm sure, or other graphics programs. But I'm going to show you how I do it in the Lightburn laser software. So anyhow, this is actually what I came up with, and this is the outline of the board, is the outline, and then the image inside is what I'm going to put on the silk screen. I'm probably going to do, if this works out, I'm going to make a 3D printed base with a slot in it for this tree to fit in. So that's why I have this extended base here. It doesn't look as good. If I had it just outlining the whole trunk and everything, it looked a lot better, but it wouldn't have been very sturdy to stand up on a stand. So that's why I did it this way. So if you happen to have Lightburn, or you probably already know this, but I figured I'd give you my how I went about getting this in the process. So what I did is basically went out and looked for Christmas tree clip art, and black and white clip art is the best because that way you don't have to deal with all the colors and everything. So I found one, so I'm going to go ahead and import it. And now let's see if I can find it. Ooh. See, I made a couple, like I said, tried to color ones and everything, but somewhere at the bottom, I think I got, here it is. So this is the tree one. Just going to bring that in. And like I said, that's just an image file, I think. It could be an SGV. I forget what it was. I think it's just an image. Anyhow, if it's an image, what you have to do to get this outline, right now I can't trace the outline of this because it's an image. It just doesn't do it. So let's see if I can scroll in. So first thing you got to do is go to these tools and trace image. Oh, I got to select the image first. All right, and all it does is kind of just trace the image, and it's saying that we don't want to delete the image, so I'm just going to say okay. Okay, so now actually you have, this is my image, and this is the traced part of the image. Okay. So now we want to trace the outline of this. So what we have to do is we have to actually grab this, and we want to separate the parts of it. So we're going to say ungroup. So now they're ungrouped. So now I can, instead of being able to just select one, I can just select, now it's just the outline is selected. Now I can go back in and do the offset shape. And I'm just going to offset 100 thousandths, in inches outward. And we're going to say okay on that. And now you can see that we have that. So at this point, I can just actually hopefully just select the outline, and then I can move it back in place over top the tree, our image. And now I can get rid of all this. So now I have the two parts that I need to do this. So got the outline, and then I got the image. So now what you have to do is you just export them. So you can say file, export. Well, you got to have something to export. Okay. So we'll do the image first. We already actually have this, but I'll just show you how you can export it if you changed it anyway. So just export. And it's going to say, it's going to save it as SGV is fine. I usually like to go and save it as a PNG. That's just my preferred one. And then you just save it. I've already done that, so I'm going to cancel. But then the outline file, it needs to be in the DXF. So we have that option too. So we're going to export. And you see you got the DXF as a option. So we're going to, you could save it, name it, and save it. I've already done that. So I'm going to go ahead and cancel out of that. But that's the workflow. And I'm sure Inkscape has a similar workflow to do that. We can go into Easy EDA, and like I say, I got this just a test circuit set up, because you got to have a circuit before you can start working on the PCB. So this is just a LED and a resistor, and I think I put one of the reverse NeoPixels in there just so I could see what it looked like with a hole in it. But anyhow, so at this point, if you want to go ahead and get that in your outline, you can just say File. Now we want to import. And if you import the DXF, it's going to figure that that you want a board outline. So you want to select your file, and I called it the tree outline. So I'm going to open that. And that's what it's going to look like. And it's on their board outline. So I'm going to go ahead and import it. And you can see, doesn't matter where I put this. All right, so now we have our board outline. And we can say that we're working on. So whichever one has the pencil is the layer you're working on. You got top, bottom layer, and then you got the top and bottom silk screens. And this is the board outline layer, so you actually got that on there. And then we really want to go to the top silk screen next, because what we want to do is we want to bring in that image. So we're going to import, and this time it's an image, and we're going to select the image, and this is just a tree. I think this one. Yep. And then the problem with images is they don't import them in the right size. So when I first did this, I had to go back to the light burn and get the exact size of this file, of this image. And because it's not, otherwise it's going to be too big or too small. So I did that, and it's actually, I think it's 9.7, I mean 3.72, I think. And if you notice, they're tying these together so it has the same aspect ratio. Of course, so when you're buying PCBs, the cheap prices stop after you get 100 millimeters, which is just under 4 inches. So that's why these sizes are the way they are. I didn't mention, but in light burn, I adjusted the sizes so that they would be just under 4 inches, 3.9 inches, I think. That was the outline. And this is the image size, and it's 3.72. So I should now be able to insert it, and it should be just about the right size. And you can move it around after you're done, but we'll put it in. Looks like I got it pretty close to right. So that's how you would create a custom outline and a custom silk screen on a board and import them. Like I said, Ralph Bacon, his lessons didn't go into that, so this might be a little add-on that'll help you if you decide you want to make a custom PCB with a custom shape. So back to my tree. So the first thing you have to do, and like I said, you'll get all this when you look at Ralph's, is to start out with a schematic. And of course, if you watched in my last video, we went through all the trouble of prototyping on a breadboard and everything. So you get it working on a breadboard first. You never just want to find something on the internet and then just draw it and copy it, because you got a good chance it's not going to work. Plus, when you go in here and you want to find these are called they're either symbols in here or footprints when you do that. But when you choose your items, you want to make sure that if you're ordering them, then you want to make sure you probably order them, or make sure you got a good part number or whatever, so that you're getting the same thing. Because this is a switch, and switches have all different shapes and sizes. And if you think, oh, I think this one looks right. And then you buy, and then you don't have a switch to fit in the holes that you make, your SOL. Like I said, so this was really kind of simple. This says it looks like a microphone, but it's actually a buzzer. So, you know, it's going to have the round footprint with just two holes to put in there. I usually keep my power rails separate, just in a box, just because I saw somebody else do that. So I usually do that. This is really basic. I'm just bringing in two holes to two pin headers that I'm just going to leave open and just put the wires in there and solder them. I do a little bit something else I'll talk about when I show you the PCB for cable management. And, I'll show you that in a little bit. So got the AT-Tiny85. Always like to have a decoupling capacitor or on in the circuit. And then I got my 15 NeoPixels lined up. And of course, you know, you got data in, data out, and then you got ground in 5 volts. Here's where I made a decision that I hope I'm not sad with. If I am, it'll be just be have to redesign the PCBs a little bit later. But if you go to if you look at any of your NeoPixel strips that you get, or any other form factor NeoPixels, you always have a capacitor with this going across ground to 5 volts on these. It's usually a 0.1 microfarad capacitor. Let's see, I think I got the data sheet up. You can see it on the data sheet. It's recommended in the data sheet to have this capacitor on every single NeoPixel. And if you look at your strips and your rings and everything, they all have them. I saw on the internet where this one guy says they're not really necessary. That's one guy. So if you believe what you hear on the internet, that's what I'm going to actually do. So this was a design decision that I made. It wasn't a cost decision. I mean, I have to go with through hole because I don't want people having to place little jelly bean size, or, you know, rice size. Actually, they call them jelly bean, but rice size surface mount parts on these boards. I think I showed you what the NeoPixel is going to look like. They have these tabs, and even though they're kind of small, I'm hoping that they're able to do it. But I'm hoping that I can get away without having them. Like I said, this one guy, it adds 30 cents to the board, but it's 15 extra through hole parts. So, and each one's got two legs. So that's a 30 extra solder joints. And I think it would add to usually I try to get these learn to solder classes down to 2 hours. And if you already got 15 pixels and then you add 15 capacitors into it, plus the other parts, I'm thinking it might go overtime. So I'm hoping that this decision is going to be okay, but I decided to leave them out, trusting what one guy says on the internet. So we'll find out I'll let you know how it works out in the final video. So anyhow, that's my story, and I'm sticking to it. So once you get your schematic drawn up and everything, by the way, the ground and 5 volts, these are called nets. So they don't actually connect to each other with these wires, but anytime you got one, this is connected to this and connected to this and connected to ground. Same way with the 5 volts. You can also have your own nets. Like if you have like a Arduino pin and you don't really have room to run a wire all the way through it, you can, you know, have a net with a pin, or, you know, name it whatever you want. So learning how to draw schematics is a little bit of a thing to learn on your, you know, that you can learn, but it's kind of fun and just one more aspect of the hobby to learn is how I look at it. So anyhow, once you have all that, then you go up here to design and you use this convert schematic to PCB, but I've already done that, so I don't need to do that. So now I'm going to go to this is my actual one. And you can see this is, I've showing the outline of board. So this is the same one that the original from the Lightburn software. So that's what it's going to look like, the outline of it. And you get these, and when you do that, create a thing, all your components are going to be down here with interconnected lines they call just rat lines because they're like rubber bands. When you move one, it just follows it along. So you have to place all these components and where you want them. I just chose, that's how I came up with the 15. So I'm going to have one up here in the star, and I'm going to make that white all the time. And the other 14 are going to be the random blink like I discussed in the first video. I just decided to put them, you know, in these little nooks in each place on the tree. I just thought that was look kind of good. And you can do auto routing. This thing has an auto router, and it might do all of it. It might do part of it for you. And then you have to kind of, if it can't get it all the way done, you can go in and fix it up yourself. But these are two-sided PCBs, so you can, what they call vias, you can change from the top to the bottom with a hole with copper in it going through the board, continuing your circuit to the other side. So that's always, you know, an option. And you can see the top layer and the bottom layer. The red lines are what's going to be on top of the top. It'll all be covered up, but it's that's what's on the top of the top. And let me see. I'm trying to see if any of them actually stop mid. Didn't look any of them stop, but you can actually at mid place you can do it. Of course, if you have like a through hole component like the legs of this ATtiny 85, you're going to have copper on the top and the bottom. So if you can see, this looks like it's the positive 5 volts. That tells you if you stop long enough. But this is 5 volts. That it's continuing on the top layer here, but the blue is actually on the bottom layer, and this line is that. But you got other things. This is the data line, and connecting them. So, you know, you can put them as long as they don't cross over. Of course, you can't cross over on the same side. So that's why you sometimes have to, you notice here, the red is underneath here. So it's kind of just cross, it's on the other side of the board. So that's how you get from one side, from crossing lines with that. Anyhow, like I said, Ralph Bacon covers a lot of this better than I can, so I'm not going to show much of that. But once you get all your things placed, you also have the option to view this as 3D. I've already got that up so we can look at it. So this is the back side. So this is what a rendering of what it's going to look like. Like I say, you can see the gray coming through because these are actually holes. And like I said, the ATtiny 85, the buzzer. Oh yeah, I didn't mention, but I did put this switch. There's no power switch. And I also didn't mention that the way this is going to be powered is I got USB pigtail cables that I ordered. I think they're 1 meter, and they just have power and ground. There's no data in them. And I picked these kind of cheap on the internet. And so we're going to have the 5 volts come in that way. And they're just going to, when you want them to run, you plug them into a USB port or a USB charger or whatever you want to put it into, and it should be fine to run. I talked about cable management. If you notice down here, you got these 2 holes in the thing. You can see the holes a little bit better here, the square holes, but I also have these 2 holes. So my idea is these red and white wires will fit through these 2 holes. I measured them and sized them to fit through those 2 holes from the back. And then my idea is to probably twist them into a single knot, wrap them around each other, create a single knot, and then push the metal part through here and solder them in. Hopefully that'll give a sort of a strain relief to the cable. I've had other projects where, people are going to do what people do, and they're going to pick it up. Plus the cable itself has some weight to it. So I'm hoping that this strain relief will help with not having the wires break off on these things. So anyhow, that was the one thing. But anyhow, like I say, I think that I've covered everything I want to cover. Oh yeah, the switch for the buzzer. I know that when I had taught kids the buzzers, after a while it'll test your nerves. And I don't care how much you love Christmas, you don't want to hear 5 buzzer music repeat continuously. But you might want to look at the lights, pretty lights. So by just turning off his buzzer, it just turns off the buzzer part. It doesn't turn off the lights. So that's going to be that was one thing that I definitely wanted to have in there. So it's fairly simple board. I'm hoping that when we get the boards in, I get the parts, the first group of NeoPixels from Adafruit, and have all the other parts, I think, to finish this. That I find that doing these pads is not too hard for people. I mean, you can see, like, these are the 0.1 or 2.5 millimeter apart on like the regular IC. So this is the distance between regular IC pins, and this is the distance between the pins on here. I know that, I think I'm going to get out like a flux pen or something and try fluxing them with flux before we flow to solder. That'll hopefully limit bridging and everything. The one good thing is you're going to have this cutout and the parts are going to be sitting there. So like a regular surface mount part, you got to worry about it moving away. And so I'm hoping that being these are set in place, I got a feeling that we're going to probably have to use tweezers or something to get these in place. I know my fat fingers probably aren't going to be able to pick up these 3 millimeter things very comfortably. One thing I notice is that they denote that the ground pin with this triangle, and if you notice the NeoPixels themselves, the ground pin has this cut triangle on it. I'm hoping that's going to be able to see what it is on the board, so we'll find out how that works out. But anyhow, I think I've talked long enough for this video. So there'll probably be one more in the series. When I get the boards back from the board house, I'll put one together and see if it works, and see if I think that, and give you my opinion as to whether it's going to work for um, learn the solder class. Oh yeah, one other thing I did put a little hole up here. This would be like if you wanted to hang it maybe on a tree or something like that. You're going to have a USB cable going down, but it's a real small hole, like for a Christmas hook or something like that. Anyhow, that's enough for today for sure. Thanks for watching. Have a great day.